Our blockchain project is focused on machine learning using homomorphic encryption to protect user data privacy and machine learning model architecture, and smart contracts to incentivize users to share their data and contribute computational power. A quick walkthrough of the flow of the application. A model creator has a model which they can then encrypt, use homomorphically, and save to IPFS. They then receive an address of the model on IPFS, which is then stored on the contract which has been deployed on the Ethereum blockchain. A data owner can then query for available models, retrieve the addresses of these models on IPFS, query IPFS for the encrypted models, train it on their data locally, compute gradients, which are then further encrypted, saved back to IPFS. The gradients addresses are then saved back to the contract on blockchain, which the model creator can then query for, retrieve from IPFS, compute the errors associated with each of those gradients, and the contract then calculates the payout from the bounty that is set by the model creator, and this is paid to the owner of the data. So a quick demo of the app actually in action. To start with, an IPFS daemon has to be started along with the Ethereum test development network, truffle develop, so this creates a bunch of test accounts. The contract is then compiled, which has already been previously compiled, so this step nothing happens, but then the contract is migrated, which means it's actually deployed onto the test Ethereum blockchain. We can see that we have a transaction and a contract being created. And this is the model repository, which is where all the models created will reside, the IPFS addresses of these models. The next step is actually to set up a model creator and a data owner and have them interact with the model repository by creating a model and training a model, respectively. So here I'm starting 2 Python servers, which are each going to be interacting with the smart contract. Here we have a model creator, where someone can create a model, upload validation data, which is used to compute the errors, and also set a target accuracy that they want to reach and a bounty that they're willing to pay for data owners to help train the model. So here you can see when the model is created, a transaction is showing up in the network, on the blockchain, and we can see that this has been logged in the truffle develop console. The next step is for someone to actually volunteer their data to help train this model. So here we have someone who has data that they would like to share. They can see the available models. Here we just have one, which is a financial lending model created previously. The user can then upload their data. So here they can upload test inputs and test labels. Their data is then submitted. And following the workflow previously, you can see that this creates another transaction on the chain, which is the gradients that they're submitting back to the model repository. The model creator can then query for these gradients and then compute the error associated with that gradient update. And here you can see that the error has decreased. There's one miner who has helped train this model, and they've been awarded a certain amount of the bounty, which was set initially by the model creator. So this is a full step-by-step walkthrough of the workflow of this application. We can see here that the data owner can also see all the models that they've contributed to and the payouts associated with each of those models that they've helped train.